Hey, it's Ivan from the EV Stock Channel here, and today we're taking a deep dive into Tesla's Giga Press and explore why other manufacturers simply don't copy it. And no, it's not just that they don't have Tesla's alloy, there's more to it. To shed some light on this topic, I'll be interviewing Andrew Albert, who works in the EV testing space and has a background in metallurgy, engineering and manufacturing. And before we begin, thank you to all the Patreons that support the show, and as always, everything discussed is our opinion only and not financial advice, so let's get into it. So Andrew, great to talk to you. Can we maybe just start off by you telling us a little bit about yourself?
Absolutely. So I've spent over a decade in the manufacturing, material science, and testing industry, both from a non-destructive testing perspective, and now I currently work in the PQT field, which is the product qualification testing field. So we test everything from electric vehicles to a lot of different aerospace parts to a lot of space things, satellites, et cetera, et cetera. So I have quite the depth and breadth of knowledge coming into this conversation.
Are you able to talk a little bit about gigacasting and what your thoughts on that are? Because I know you've got some experience and expertise there.
Absolutely. So I have a slide here called Giga Casting Game Changer ? Right? It's absolutely a game changer, but let's kind of explain why, again, kind of to more maybe someone who hasn't spent a good amount of time in manufacturing. So there's really four main ways to manufacture something. So the first one's subtractive manufacturing. So you basically take a block of metal, you'll remove some percentage of it, as much as even 90%, and you create a finalized part. This is typically what you see in aerospace because of the demands of the part are so high. Then you have what's called additive manufacturing, which is 3D printing. We're all familiar with that. But there's kind of the next generation of that. There's a couple good companies out there, one of them being a company called Desktop Materials. And as you see here, Porsche is actually 3D printing their EV motor cases. And that's what's a photo, just a stock image from Google, but widely known. It's stronger than the cast case, and it's also 45% lighter. So again, weight is really important. Weight savings is really important for EVs. So I think Tesla's going to start pursuing that probably in the next couple of years for more smaller components. But 3D printing really doesn't scale quite that big, and it's really slow. So in this case, it would be uneconomic. The fourth thing would be forming, which you see down here in the bottom right, which is traditional frame rails for traditional automobile, which is kind of how we do it today, is chassis on frame. It's really also, again, kind of not the way to do it. It's not really a first principles approach. It's dirty, it's messy, it's also kind of slow, tons of robots, and your kind of critical path. It's very similar to how Tesla was doing it. One particular robot or one little section of the line goes down, or you're missing one particular component, and everything comes to a screeching halt. This Giga Casting fixes all that. So when you're casting, again, there's kind of some issues with casting. This is where Tesla, having the SpaceX team and having a gentleman that kind of crosses back and forth, I forget his name, but he's a pretty famous guy, was able to develop their own alloy. And this is why it's really important. So for two reasons. The image in the middle with that pretty serious crack in it is what's called a shrinkage crack. So there's what's called CTE, coefficient thermal expansion. So if something gets hot, it expands, and then as it cools, it shrinks. Well, since metal's really dense and it has to shrink, a lot of times the metal will crack because it's trying to make, be smaller than its natural state. So when you do casting, shrinkage cracks is really kind of a production killer and really drops your yield. And the image to the right is what's called cold shot. So if you have a very complex shape or complex mold, as the metal's coming into the die, you might get some sort of almost like a wave effect, to where as little dots or little drops of metal cool, they get remixed in with the rest of the molten metal, but they're at a different temperature. So now you get these either gaps, which is called porosity, or you get these kind of bimodal distributions of grain size. So if you see a lot of it, they're nice little round, tight circles, all kind of common size. And then you get these blobs, and you don't want that. That creates all sorts of weaknesses in the casting. And if you get enough of those in a particular area, that can create a failure under any type of force. So you're driving down the road, you have a bunch of cold shot in your casting, you hit a pothole, and now you have a broken frame of your vehicle. And especially as Tesla moves from, in an integrated pack, that basically would total your car, more or less. Your frame is now broken, your battery pack is unsupported, it would be a bad day. So what they really had to do is go back to kind of, again, a first principles approach to come up with an alloy to prevent shrinkage, because they need this machine to cast the chassis, be able to release, quickly move that giga casting to an area to cool, preferably again with some sort of airflow or some quench to quickly cool it down to now they can add that to the assembly line and start building a car. Because if it takes hours and hours and hours to cool down these castings, you're now like storing all these pieces of hardware versus a single piece flow, which again is less than ideal. And then the picture here on the left is what's called ultrasonic inspection, which is how you would do subtractive manufacturing. And you basically you're looking for internal defects. So again, if you're kind of doing that forming style, or you're starting with subtractive manufacturing, which is uneconomic and really not the right approach. If you really wanted to make sure that you have everything dialed in and good quality certified material, you'd have to do 100% inspection. Doesn't really lend well for what that intent is.
And we know who was the one that invented the TSLA? Was it Tesla? Was it SpaceX? Or was it someone else that Tesla and SpaceX, contacted?
I don't know the particulars on that. I know that there's one guy who's one of their top material scientists. I think he's been kind of working for Elon as one of his inside guys for over a decade, or approximately a decade. And I know that he kind of drifts back and forth. I think he even has a split work week. This is kind of common knowledge. But the metallurgy folks, and a personal friend of mine is a metallurgist at SpaceX. He's one of the smartest guys I've ever met. And their team is very, very good. So I have no doubt that from a metallurgy perspective, they should not have any, pun intended, material issues with the casting.
Yep. So can you talk about how much of a saving this is for Tesla in terms of, how many robots, are no longer needed, how much space is saved? What are the overall costs and speed of manufacturing, and also the quality?
Yeah, it's just absolutely insane. I think again the 4680 and the Giga casting are two completely understated and underappreciated, non-understood aspects from, again, kind of the lay folks who haven't spent time in manufacturing. Robots in general are pretty finicky. I've worked with all the big robot brands for many years of my career, and they have issues. They need to be super precise. A lot of times they're working in like really tough environments. A lot of times, like the software is written by this company and the machine's built by this company and it's serviced by this contractor on this continent. So it's kind of like this hodgepodge. There's a lot of finger pointing. It's just a problem. And when you have that many robots and every single one of them could have the slightest issue or be 20 millimeters off, and it creates a line stoppage, it costs you millions of dollars an hour in lost revenue. It's just non-economic. So from that point of view, and then kind of going back to the CPK side of the house, is like, again, public knowledge is like how many parts go into one of these front assemblies or rear assemblies for the Model 3, Model Y. Every single one of those panels has its own CPK because you're producing a part. So if one of the parts is short or dimensionally or what have you, it just is a game changer. Like it's a showstopper. It's really a bad way to build a car. I think in many years, next couple of years, the Giga casting is going to become somewhat ubiquitous in the automotive industry, as long as the other automotive makers have the bravado to take on a challenge like this, because it's completely new and it's kind of the devil they know versus the devil they don't.
So what's the limiting factor for the other auto manufacturers to start implementing this? Is it not having, access to that alloy that Tesla has? And is that something that Tesla could license?
So I don't know if you can patent a metallurgical kind of recipe, if you will. If they could, I think Tesla should do that. And then I really don't know how much like the competitor's recipe would have to differ to achieve the same result, yet circumvent the patent. So probably have to be someone who's kind of like a very sophisticated legal person. I can't really adjudicate that one, but I will tell you the Giga casting is, in my personal opinion, is not an unbeatable moat. I think this is something that could be replicated probably inside of 24 months. If you really break it down by components, it's not that hard. So on the slide here, we have what's called spectrochemical analysis or spectroscopy, and also what's called a PMI gun, right? So if you were to take some metal to a scrapyard, they would quickly shoot it with this handheld device, and it will give you a rough breakdown of how much copper's in it, how much steel, how much aluminum, how much titanium, et cetera, et cetera, et cetera. And these guns can be owned for like $10,000. They're super cheap. And then spectroscopy is done, or spectrochemical analysis is done in a metallurgical lab. And if you live in the United States, I bet there's one of these labs within 100 miles of your home. I'd almost guarantee it. They're all over the place. They're tucked away in little business parks, and there's many more of these than you would recognize. And you can take a piece of that metal into a lab like this, and they could give you an analysis within hours for less than $1,000. This is not a hard test. You can see the machine here in the photo. It's very simple to run. A high school student could run it, and you could get that recipe. So that's kind of like the main piece. Again, it's like it takes a long time to find it out, but very easy to replicate. And you kind of see this with 4680, where there's already now two of Tesla's supply chain people, the battery companies, that are now mimicking this cell and have plans to make a similar cell, inside of 18 months. And I think the Giga casting is even easier to replicate than a 4680.
Wow.
So again, back to the three pieces is number one, the recipe of the metal, which is common knowledge now. I think Sandy Monroe recently shared some facts about that. Then you have the machine itself, Idra, they're out of Italy. The Italians are great machine builders. And then molds, there's tons and tons of mold makers, especially around kind of the automotive legacy area, Midwest, Illinois, Detroit, that type of area. The Germans, huge into machining. The Chinese now are really getting spun up, the Koreans. So I don't think you'd have trouble sourcing the molds. I'm pretty sure Idra would be happy to make you a Giga machine. And the recipe, again, I think is probably one of the easiest things to kind of figure out and mimic.
Are there other companies that make the Giga presses?
I'm sure there's a lot of companies out there that make presses. As far as a one that size, I don't know of any. I kind of saw a headline the other day that some Chinese companies are kind of looking at. It's actually the parent company of Idra that is looking at making some oversized presses. I think even a 9,000 ton. But I really don't see any type of like showstoppers in regards to how big you can make one of these. I think there's a point to where you'd probably get it like a diminishing return, but I think that we're just getting started, and I think this would be pretty ubiquitous in 5 years.
Yep. Yeah, the only reason I ask is because I'm just wondering if it's a unique process to Idra, because if, for example, some other auto manufacturer sort of wants to improve their situation and harm Tesla, what if they buy Idra out? Like, what would then happen to Tesla? Would they be able to go to someone else? Then does that mean Tesla should be looking at, acquiring a company like this, because as they build more and more factories, they're going to need more and more of these presses. So they may want to sort of secure their ability to purchase these presses, for many years to come.
Yeah, absolutely. I think it's kind of hard to buy everybody, and I don't think Tesla necessarily wants to be in the press business. But I definitely think they could probably set up some sort of purchasing agreement that has like staying power, to where even if there was an acquisition or something along those lines, they would be guaranteed some supply in perpetuity, to ensure that production doesn't get shut down and they don't have to reinvent the press.
Yep. Yeah, the only other thing that I was thinking was, for other companies, say like VW, Toyota, like I'm surprised they're not getting into Giga presses, because for every vehicle you make with a press, you're saving a large amount of parts, time, and dollars. And considering the volumes these other manufacturers are doing, their savings would be way more than Tesla savings, because they made 500,000 cars last year, compared to 5+ million for some of these other auto manufacturers. You'd think they would be, doing everything they can to switch to Giga Press ASAP.
I think there's a couple different hindrances there. I think number one, probably a lot of the equipment, like these automakers, majority of them operate on huge amounts of debt. If you look at Ford, I think they have $124 billion in debt with about a $40 billion market cap. So obviously there's a lot of equipment that's financed there that isn't paid off yet. So to now dispose of an asset that still is, you're making payments on, that isn't paid for, and to try to be on the bleeding edge with a company with world-class engineers, it's pretty tough. So I definitely think that they're looking for a little bit more maturity, and they're probably looking to kind of go from a completely new, I don't know what the word would be, I guess, kind of like a redesign, or to start fresh with a new iterative model. that is built around the gigacasting versus taking an existing model and try to Frankenstein it to accept a gigacasting would be a more palatable way to do it.
Mm. Yeah, because you think that you'd need some sort of leader in one of these corporations that could sort of run the numbers and say, look, even though we've got these other machines in place, I mean, if we can switch the Giga Press, we'd be saving X amount from day one, and they won't have to like sort of switch over, you know, all of their factories all on day one, but they should start coming up with a plan to say, look, we can sort of put in a few Giga Presses here, a few Giga Presses there, and then build them in over time, because the amount of dollars that it could save would be huge. I mean, all they would have to do is potentially, you know, someone needs to have the balls to say, all right, we're not going to be paying dividends for 2 years, because this is going to make such a massive difference, you know, for our manufacturing and our margins, that it's going to put us in such a strong position. So that's just what I'm thinking.
You're absolutely right. And to that slide, I'm saying, is it a unbeatable moat? I don't think it's an unbeatable moat in the sense of how hard it is to replicate the technology. I think it's more of an unbeatable moat in the sense that these other automakers are so saddled with debt. They're so entrenched in their processes. They have executives that are afraid to kind of think outside the box and take risks that would put their career in jeopardy. And I think they also probably have a lot of long-term relationships that would be dramatically bruised given this completely change in the way they manufacture cars. I'm sure they're super aligned with, you know, all the big robot builders, Fanuc and KUKA and the others to, you know, there's probably a lot of cross-pollination there with employees and things like that, to where it would be hard conversations and probably having to pay penalties of exiting contracts and supplier agreements, and it gets really complicated at that level. So I think as kind of things sunset and they're ready to go to the next phase, I definitely think this would be adopted. And they want to be on the leading edge, not the bleeding edge. This is not an easy thing. I've gone through development for most of my career, and it's really tough. It is really tough. And like Elon says, like, prototypes are easy. Full-scale manufacturing, with the caveat of being profitable, is excruciatingly hard. Really, really hard. So I think there's a lot of people that are going to have a hard transition in the next 2, 3, 4 years.
So I hope you guys enjoyed that interview, and let me know in the comments if you guys have any questions for Andrew, as I'm going to be having him back on the show. So this is your opportunity to ask Andrew any questions that you want in relation to any engineering topics. So that wraps up this episode. If you enjoy the content, please consider supporting on Patreon, and until next time, I'll catch you guys soon.